Hello again, this is Professor Gavoor. We're going to cover Chapter 4, which is about demand elasticity. And this will be the last chapter we cover for week 2. So it's we're going to cover the economic concept of elasticity, spend a lot of time on price elasticity, a little bit on cross elasticity and income elasticity, and then one slide, I believe, on other elasticity measures. And then elasticity of supply, which probably should have been covered right after elasticity of demand, but it's not the way the slides were structured. So we want to define and measure what this concept of elasticity is. Look at the concepts of of elasticity and apply them. Understand the determinants of elasticity and show how it affects business revenue, which is ultimately the most important part. Elasticity is the part of microeconomics that really drives the price theory. When can we take a price increase? When should we not take a price increase? What impact or not or positive or negative will it have on revenue? So as I said, another name for microeconomics is price theory. When can we oppose this price increase? You know, the law of demand is the quantity demanded depends inversely on price, or the higher the price, the lower the quantity that will be sold. And which one moves more fast or faster at a higher rate? The price increase or the lessening of the quantity sold? So depending on which one makes the bigger jump, that answers your question whether their revenue will go up or down. So remember, revenue is price times quantity, P times Q. If we raise the price, the quantity will fall, so the new revenue will be. So we add P plus delta P, which is a change in price, and we multiply that Q minus delta Q. Oh my God, we have to remember the FOIL method from 10th grade algebra? Yes, these things never go away. It's just you probably never use them, more likely than they never go away. And I think there should be some of this analytic capability should be in all business majors, including MBA. So remember, you multiply the first, P times Q. You multiply the last, P times minus delta Q. So it becomes P times minus delta Q is there. And then you multiply the outer, P times minus delta Q. Right there, the inner, delta P times Q. Right there. And then you multiply the last. So you get negative delta P times delta Q. So P times Q is a positive number because remember, both price, delta P, quantity, and delta quantity are positive numbers. The negatives, the ones that will be subtractors from this are P times the change in quantity and the change in price times the change in quantity. These, if it was just left up to these two, there'd be a positive increase. But here we got the negative part. So it really depends on how big these are. Elasticity is a percent change in something divided by the percent change in something else. That's how economic elasticity is measured. Usually, it's the percent change in the quantity of something versus the percent change in the price of that same something, or the economics, the dollar value of something else. And we'll talk about that. So let's talk about price elasticity of demand. And when most people talk about elasticity, I don't know, rule of thumb, 80% of the time they're talking about this. So for a given product, elasticity of demand, which for some reason this book uses E sub P, every other book I've seen uses E sub D for demand, price elasticity of demand. And maybe it's price they're focusing on here, but everybody else uses ED. So anyway, it's a percent change in quantity of the good divided by the percent change in price. Now the formula for this is Q2 minus Q1, that's a change in quantity, And then they use what's called the midpoint formula. Q1 plus Q2 divided by 2. So it's really the average of the two quantities. So EP is called the arc price elasticity. It's between 2 points. Q1 is the original quantity demanded. Q2 is the new quantity demanded. P1 is the original price, so Q1 and P1 go together. And then as an ordered pair, Q2 and P2 go together. The new quantity demanded, new price. And you divide this, division. So they didn't make it a big, they used the division sign instead of making a big fraction out of this whole thing. So the difference here is P2 minus P1, and then the average of those. Now, there are also formulas that do the absolute value around these so that everything comes out positive. But this will either be positive or negative depending on the direction you go. So if one direction is positive, the other direction may well be negative, depending on what the original and the new one was. There's another one that's called the point elasticity. It's elasticity measured at a given point of demand. So it's a change in quantity divided by the change in price times the original price divided by the quantity. I don't know how often we'll use this. We tend to use in this elementary class this, but this is leading itself to calculus. As soon as you have change in quantity divided by change in price, you end up with the ability to use calculus and take the first derivative. Because you let delta P go to 0, and that gives you the elasticity, the point elasticity, which is the derivative Q divided by the derivative of Q with respect to P times P1 over Q1. So the derivative of Q with respect to P is simply the instantaneous version of the slope. And there's a mathematical review in this chapter that introduces this little bit of calculus and shows you how to do it. I'm still debating whether to put up a video on that or not. Remains to be seen. Price elasticity of demand. An example of nonlinear demand curves, there's one that has constant elasticity, and it's actually an exponential curve. And its Q equals A times the price to the minus B, where minus B is the elasticity coefficient. That is the only one that has constant elasticity throughout the entire curve. And that's kind of rare in economics. Most of the time, if we look at a linear curve, there's a couple regions here. There's a certain point where there's unit elasticity on the line. Notice we're taking a percent change in Q. So the percent change in Q here is huge, right? Because the denominator is going to be very small. It's going to be small numbers. But the percent change in price is very small. So the percent change in quantity divided by the percent change in price, it's going to be greater than 1 here, which is the definition of elastic. And it decreases in elasticity until it reaches 1, or these are all going to be negative, because if we're going from here to here, they'll all be minus as we calculate elasticities going down this curve. We get unit elasticity of -1 here, and then it becomes inelastic. In other words, the percent change in quantity is smaller than the percent change in price. Because of the divisor. If I go from 2 to 3, if I go from 1 to 2, it's 100% increase. Or 2 to 1 is 100% decrease. 50% decrease, sorry. But then you're only going from, 16 to 18 or something like that, and you're dividing that by 17. So that same unit of difference of quantity of 1 or 2 divided by 17 is different than the quantity of 1 or 2 divided by 2 or 3 down here. You have to make sense of this, and you have to actually do some calculations to see this. So relative elasticity of demand is when it's greater than 1. Relative inelasticity of demand is when it's between 0 and 1. It's unit elastic when it's 1. The same thing applies when it's greater than less than -1, and between 0 and -1. It's relatively inelastic and relatively elastic. Perfect elasticity is when elasticity is infinity, which means the change in price is 0. The price is fixed. And unit elastic is when the quantity is fixed. The numerator is 0. So factors affecting demand elasticity is ease of substitution. If you can replace one product with another, then your product is, it's inelastic. If you raise a price, it's very elastic. I mean, you're going to change your price a little bit. Your change in quantity is going to be big because I could use something else. And substitute products are hot dogs, hamburgers, coffee, tea, anything that you could replace. Oh, gee, the price of that went too high. I'm going to go here. If Starbucks makes their coffee too much, I'm moving to Keurig. Those would all be proportion of total expenditures, durability of the product. Can I possibly postpone the purchase? Possibility of repair, used product markets. Right now, most people, if they're thinking about buying a new car and this COVID pandemic hit, they're postponing their purchase. If I have a refrigerator, I had a refrigerator that was used for beverages. It came with the house. I didn't know. It looked like a little refrigerator. It looked like a dormitory refrigerator to me. It went out. So I figured, might as well just buy a new one. They're like $2,000. I was like shocked at how expensive they were. So I called the guy and we could repair it for $400. Okay, so I did that. And used product market. That's become with Marketplace on Facebook and such places like that. We bought an entire dining room set that was probably, I don't know, I think if we bought it new, it was like $10,000. But we got it for like $250 because people were moving and downsizing, and it fit perfectly in our dining room, and what a steal. And length of time period. Okay. So derived demand. The demand for products or factors that are not directly consumed but go into production of another final product. So this is like the bill of material. The demand for such a product or factor exists because there's a demand for the final product. Tires, for example, is driven by the demand of cars to a large extent. Of course, there's replacement tires. But hard drives generally go into new computers. That's probably the large volume of sales, even though you can have external hard drives used for backup and all of that, which probably use the same technology. But ink refills, they go into pens, that kind of thing. The drive demand curve will be more inelastic. The more essential is the component, the more inelastic is the demand curve for the final product. The smaller is the fraction of the total cost going into the component, the more inelastic is the supply curve for the cooperating factors. So remember, elastic means small change in price, percentage price, yields a larger percent change in quantity. So when I divide percent change in quantity divided by percent change in price, I've got a bigger number divided by a smaller number. It's going to be bigger than 1. That's elastic. Small change in the percentage change in price yields a larger change in a percentage change of quantity. It's inelastic when the percent change in quantity ends up being smaller than the percent change in price. So if I take a price increase in an inelastic product, my quantity goes down by a lesser percentage. My revenue will probably go up. If I take a percent decrease in price, my revenue probably won't go up as much. So if it's elastic, you want to take a price decrease to increase your sales and probably increase your revenue. Price elasticity of demand. In the long term, if you look at the long-term demand curve, will generally be more elastic than the short-term curve. This is dependent. Elasticity is dependent on the slope of the curve or how quickly the curve declines or increases. So here's some demand curves at different demands and different periods of time. So notice the slope is pretty stiff. So if I have a small change in quantity yields a large change in price, or a large change in price translates to a very small change in quantity all the time. Now, if I look at a variety of points across here at different price points, so I look at the same price points here and here, or if I look at my equilibrium points in the marketplace and plot all of those. So if this is the equilibrium point for this demand and given the same supply, blah, 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 I have a long-range demand curve. And this is the change in demand over time, assuming supply is the same. So I have my long-range demand curve here. It's much flatter. So now a small change in price yields a larger change in quantity. But percentage-wise, it's different. So a long-run demand curve will generally be more elastic than a short-run curve. Think about gasoline. Gasoline is relatively inelastic in the short term. It's almost a picture like this. If they raise the gasoline prices 50 cents, some people are going to not drive as much, but most people have to drive to get someplace. The only time that's not working is right now in this COVID thing. Gasoline is probably $1 less, and people are driving a lot less. So gasoline sales are in the tank. But assuming a normal period, if gasoline prices go up or down 50 cents, people are not going to drive that much more or that much less. So it's relatively inelastic in the short term. But in the long term, if gasoline prices keep going up, people will buy more and more fuel-efficient cars and maybe move more and more to electric cars, which we see happening. And therefore, that long-range demand curve is more elastic. And people behave and react that way. So price elasticity of demand. The relationship between price and revenue depends on elasticity. Why? Because price itself, the price fall will reduce receipts. But because the demand curve is downward sloping, the drop in price will also increase the quantity demanded. So which effect is stronger is what we're asking about. So if you have a price increase and it's elastic, total revenue goes down. If you have a price decrease, a price increase when it's elastic, total revenue goes down. If you have a price decrease when it's elastic, your revenue goes up. So if you're in an elastic region of the demand curve, if you want to increase revenues, you drop your price. You have a sale to increase your revenues. If it's unit elastic, total revenue remains flat. It just doesn't change. When it's an inelastic region, you have the following. A price increase will raise your total revenue, and a price decrease will reduce it. This is what a lot of managers and businesses struggle with every day. They want to take a price increase. We'd like to take a price increase. Can we take a price increase? Well, in one case, a price increase will reduce your revenues. In another case, the reason you would take a price increase is to increase your revenues. In other words, the percentage change in price is bigger than the percentage decline you would get in quantity. Then your revenue is going to go up. But if you're in the elastic part, and most people don't understand where they are, because I don't know if they do that economic analysis. I don't think most companies do it. But you have a feel for it, and that's why you study microeconomics, to understand this. If you're in the elastic, if you're taking a price decrease and you're in the inelastic region, you're not going to increase your revenues. You're going to decrease your revenues. So why would you want to have a sale? Why would I have a price decrease when it's going to reduce my revenues? I want to have a price decrease when it's going to increase my revenues. And that's why price theory is so important here. You want to know when to take an increase and when to take a decrease, because in both cases, you want to increase revenues. If you look at the curve this way, and this is like reducing price. In other words, price should be on the x-axis, but it's not. We've talked about this in the last one. This is the economic way of looking at things. Quantity is the x-axis. In this case, total revenue, the dollar amounts are on the y-axis, the price on the y-axis. So here's what we're doing. We start here. We're starting right here when revenue is 0. Or maybe a little bit inside when it's at 2 or 4 or 3 or whatever. We multiply price times quantity. And as you see, as you go down, as price decreases, the revenue increases till it peaks out at unit elasticity. Then, as price continues to decrease, your revenue starts to decrease as well. And it's symmetric about the unit elasticity. So if you're in this region, if you're in the elastic region, increasing prices is good. You'd like to increase it to become unit elastic. That's where you maximize your revenues. And then you will decrease your revenues thereafter. It's an important curve. All right, so marginal revenue is the change in total revenue resulting from the change in quantity by 1 unit. So for each unit of quantity that we increase or decrease, what happens to our revenue? So marginal revenue is the change in total quality. Total revenue 2 minus total revenue 1 divided by Q2 minus Q1. And if you make this, always look at where the change in quantity is 1, it just becomes the change in total revenue. The marginal revenue curve is twice as steep as the demand curve. We can do the calculus to show you, trust it. Whatever the slope of this is, the slope of the marginal revenue curve is going to be twice that. So if this is like -5, this is going to be -10. Both are going downhill, both are linear, so we have that. At the point where marginal revenue crosses the x-axis, so I have positive marginal revenue, I'm increasing but at diminishing returns. If you look at this picture, my revenue is increasing dramatically and it's slowing down until it gets to unit elasticity at this point. It peaks out and then it starts to slowly decrease, and then it decreases very fast. As the price goes down, the quantity goes up, but I'm not making, 2 times 16 is 32. 2 times 16 is 32. So you're here in both those cases. But if I'm going to, 4 times 14, whatever that number is, and then 4 times 14 here, it's very nice and symmetric. we end up with that. Linear demand curve, parabolic, quadratic revenue curve. And if you look at the revenue curve, it is definitely, if you put P, it is definitely a quadratic. So that's what we're experiencing here, and that's what you've got to kind of understand. Now, how do you understand this? You want to read the book, you want to watch this video, you want to try to do some problems to explain that to yourself. So coffee, short run, minus 0.2. Inelastic. Long run, it's more elastic, but still not much. People like coffee, is what it says. They're not going to substitute for other things. Yeah, I can substitute for tea. Some people will, but most people stick with the coffee. Kitchen and household appliances. The elasticity is 0.63. I don't know if there's a short or long term for that. Meals at restaurant is minus 2.27. It's very elastic. A change in prices will drive people away. Airline travel, minus 1.98. I shudder to think what it is now. The price is low and still there's no demand because of this COVID thing. We're in a different world right now. Everything has been reset almost. Oil demand in the short run, remember we said it's inelastic. It's strongly inelastic because people have to drive. In the long run, it's more elastic, but not by that much. Other examples, white bread, 0.7. People either need bread or they don't. Oh, there's my phone. I wonder who's calling. My mother-in-law. Hopefully my wife will get it. Cigarettes, in the short run, is 0.4. In the long run, it's 0.6. I don't know when's the last time they calculated it, but let's assume that this is... and let's wait for that to end. All right. In the short run, it's 0.4. In the long run, it's 0.6. So you have to know that if you're placing taxes against cigarettes. Taxes make the price go up. And it's not so much the tax that has made cigarette smoking go down. That's certainly helped a little bit because you can see in the long run it's a little bit more elastic, but still in an elastic zone. The thinking is the constant advertising, public service announcements against smoking, and of course every municipality in the country basically not allowing smoking in any public places. That's had the biggest impact. Well, wine imports, relatively inelastic. People like wine, they're going to keep buying wine. Crude oil is not so different than gasoline. Well, I don't think we had gasoline before. And internet services, relatively inelastic, short-term, long-term, only because people need the internet. They probably need it even more now. Cross elasticity of demand. This is a different kind of elasticity measure. We're talking about the percentage change in quantity consumed of one product versus the 1% change in the price of a related product, or depending on what the percent change is in the price of the other product. So I've got two products. What happens to the cross elasticity of hot dogs and hamburgers? What happens to the things that are either goods are complementary, or goods are substitute, or goods are completely unrelated? If they're completely unrelated, the change in price of one probably shouldn't affect the quantity consumed of something else. Ice cream and automobiles. So if automobile prices go up or down, I don't think people are going to change their ice cream very much. But if the price of milk, a component in ice cream, goes up, people may, that will affect the price elasticity. That will affect the amount of ice cream consumed. If the price of hot sauce goes up, and that would affect the consumption of ice cream. If people only liked ice cream with hot sauce, chocolate sauce, oh my God, that would be an interesting thing. So if we look at it, it's the same kind of formula. So we got the percent change in quantity of A versus the percent change in the price of product B. You can look at it this way as well. Percent change in A divided by the change in quantity A divided by the midpoint quantity A divided by the quantity change in B divided by the midpoint of B. So the cross elasticity of substitutes is positive. If the number comes out positive, that means, and what is a substitute? I can substitute one good for the other. Coffee, tea, I can do hot dogs, hamburgers are probably the best examples of that. Complementary products are hot dogs and hot dog buns. It's ice cream and chocolate sauce or hot fudge sauce. If one goes up, the other goes down. So two products are considered substitutes or complements when the coefficient is larger than 0.5 in absolute value. So I would say when the sign, if it's positive, if it's complementary. If it's negative, it's substitute. And two goods are considered good substitutes or complements when the coefficient is larger than 0.5 in absolute value. So large, for the sign of cross elasticity for substitutes is positive. If it's greater than 0.5, they're good substitutes. If it's minus 0.5, they are. If it's negative, they're complementary goods. And if it's less than minus 0.5, they're good. They're considered good complements to each other, but more related. So cross elasticity of demand examples. Residential demand for electricity energy with respect to the prices of gas energy was low, about 0.13. So people either use gas or they use electric, and there's not much in between. Electric heat never really took off. I think you might have electric heat in areas like where it doesn't really get that cold, and if you need some heat, you're willing to pay a little extra for electric heat and not have to have a gas line in your house. The cross elasticity of demand for beef with respect to pork prices was calculated to be 0.25. With respect to the prices of chicken, it was about 0.12. Both numbers indicate that the products are substitutes, but they're not good substitutes or strong substitutes. People will still buy beef or pork. So income elasticity. This is an important one. It's the percent change in the quantity of a product you buy with the percent change in Y. And Y is the shorthand for income in this case. So here's, again, the formula for this. The formulas will all look the same. It's just instead of P, they're using Y. And in one case, when we did cross elasticity, it was a quantity of one versus the price of the other. When it was elasticity of demand, we used quantity of that product and the price of that product. So when income elasticity is greater than one, we define it economically as a superior good. When it's between 0 and 1 on the positive side, it's called a normal good. When it's less than 0, it's called an inferior good. That means if the percent change in price your income goes up, you're buying less of it when it's an inferior good. It doesn't mean it's a bad good, it's just an economic term that we're using. A normal good is, okay, the more you make, the more you buy. And a superior good is almost like a luxury good. So inferior good is a product whose consumption decreases as income increases. And a normal good is a product whose consumption increases as income increases. A superior good is obviously similar to a normal good, is an item for which consumption increases as income increases. But unlike a normal good, its income elasticity is always above 1. So superior goods are always expensive and relatively scarce or harder to come by. They're purchased in place of a lesser quality item, therefore making a larger proportion of consumption as income increases. And it might be a luxury automobile, while a normal good could be an average automobile. So think luxury goods when you think of superior. When you think of inferior, what happens when we hit a depression or something like this? You're trying to conserve your money. You're going to buy lesser cuts of meat. You might buy flank steak instead of tenderloin if you're eating beef. You may go to the shampoo aisle and decide that, oh, I'm not going to buy the premium or the name brand that I always buy. I'm going to buy maybe a more generic brand of a consumer goods. All consumer companies, good companies, have a normal and an inferior good in their portfolio, like Colgate-Palmolive. They have their Colgate toothpaste. That's their normal good. But they have a bargain brand. And that's really the better way to think of as an inferior good. It's kind of a bargain brand. Their bargain brand is called Ultra Bright. It's still a decent toothpaste, but it's not their premier. It doesn't have the most technology in it. It doesn't have the surfactants and additives that make Colgate Total the toothpaste that it is. So we're back now to, as your income goes down, you're going to buy more inferior goods because you want your money to go longer if you're unemployed than buying your superior goods. Now, a normal good is like you're going to buy more toothpaste, or you're going to buy more tenderloin when your income goes up than not. Everybody's calling me all of a sudden. I'm sorry about that. So income elasticity examples. Short run income elasticity for food expenditure is about 0.5. And the elasticity for restaurant meals is much higher. People will eat at home if their income goes down. The short run income elasticity for jewelry and watches appears to be 1, and a long run 1.6. For gasoline, in the short run, income elasticity is between 0.35 and 0.55. Long run is between 1.1 and 1.3. So income elasticity for gasoline. You know, if in the short term, it doesn't really matter because it's inelastic. You need to get to where you're going. In the long term, if you get more money, do I care if my car only gets 10 miles a gallon or my car gets 50 miles a gallon? The cost of the gasoline doesn't have an impact on me. So let's look at some other elasticity measures here. Elasticity is as long as I can take the quantity of a good and do it by the cost or the price or the dollar value of some other thing, I can create an elasticity measure. So we can look at advertising expenditure, percent change in quantity divided by percent change in advertising expenditure. That's a great measure from a marketing standpoint. If we spend more on advertising, will we get the quantity change that we want? And we'd like that to be elastic as possible. Interest rates, same thing. Does a percent change in interest rate increase the quantity of loans? I mean, why does the Fed lower rates? Because they think they're going to increase the amount of loans at a higher rate and stimulate the economy. Population size. Not sure exactly how that goes, but change in population and change in quantity for a product. Many things will be elastic relative to population. Population goes down, and it might be a segment of population. You know, you see in many European countries and the United States an aging population. How does that affect the sale of various products? Lastly, we want to talk about the elasticity of supply. It's just like the elasticity of demand, except it's on a increasing, supply curves are increasing and slow. And so it's a percent change in quantity supplied divided by the percent change in price. Similar formula, exact same formula as demand, except we're talking about a supply curve, not a demand curve. When the supply curve is more elastic, the effect of a change in demand will be greater on quantity than on the price of the product. And when the supply curve is less elastic, a change in demand will have a greater effect on price than on quantity. So if we look at price elasticities, imports are always price inelastic. You don't have any other choice to get them, at least in the short term. If exports are price inelastic, export earnings will rise as prices rise. If exports prices are elastic, export earnings will rise with world incomes. So exports, if you can export and you have that kind of elasticity, you're doing well. So if you look at different countries and you look at the import price and income elasticity and export price and income elasticity, so they look at all the prices of things they sell, you have a sense everything is negative except the income elasticity here. Sri Lanka's price elasticity, export price elasticity is positive, and income elasticity is positive in 3 countries out of the 5 that they're looking at here, and import price elasticity of price or demand, is all negative. How do you interpret that? So elasticity is defined as the sensitivity of a variable versus another variable. Oftentimes in the numerator, we use a quantity, and it's a quantity of a good that's sold. And the denominator is oftentimes an economic factor, like the price of that product. And that applies for both elasticity of demand, elasticity of supply. But we can also relate it to cross-elasticity, the quantity of one product versus the price of another product, the quantity of a product versus income elasticity. When we look at cross-elasticity, we're talking about, this brings in the idea of substitute and complementary goods. So price elasticity of demand, we talked about that. The demand is elastic. Revenue rises as quantity demanded increases. Revenue reaches its peak at the point of unitary elasticity and descends as quantity rises on the demand curve and price goes down. Cross-price elasticity, the relationship between the demand for one product and the price of another, as we said, and income elasticity we also summarized. Thank you very much, and we will be with you again for Chapter 5.